Let's see this question. We want to integrate 3 times z to the e to the x squared plus y squared over this given cylinder. So x squared plus y squared less than or equal to 2. So we can draw the picture. Imagine a circle on xy plane. The radius is 2. Right? It's all this. Right? All this. Then z goes from 0 to 3. So that means that the dimension z to have this cylinder. All right, so that's the object we want to integrate. We want to integrate the integral with 3 times z times e raised by x squared y plus y squared. Right, maybe we do dx, dy, dz, because z is given upper limit and lower limit. So z goes from 0 to 3. And we can fix y direction or not. Let's see y direction. Let's think of this as y direction. And this as x direction. Right? Because this x squared plus y squared less than or equal to 2, so we can write negative 2 as square root 2 squared. So we know the radius is a square root 2, not 2. The radius is square root 2. Right? Remember, x squared plus y squared equals to 2 squared. Right? That's the description of a circle with a radius of r. So in this case, r equals square root 2. So we see y goes from negative square root 2 to positive square root 2. So y direction we can, so lower limit is negative square root 2, upper limit is positive square root 2. Then x goes from the lower half semicircle to the top half semicircle. So it's negative square root of 2 minus y squared and positive square root of 2 minus y squared. Okay, so we have set this up, but it's difficult to integrate as this. So we want to use the cylindrical coordinates. In cylindrical coordinates, we have r squared equals to x squared plus y squared. And we have dx, dy, dz equals to Jacobi, change of variables, r, dr, d theta, dz. So we want to use this. So then z direction doesn't change. Z still goes from 0 to 3. But then we don't use, so we're going to use d theta, dr, but we have this Jacobi r. Then we need to change, so d theta, we see we have a circle, right? So the angle goes to 2 pi. So angle goes from 0 to 2 pi. And the r goes from the center, 0, which is 0, the origin, right? 0 to square root 2. So r goes from 0 to square root of 2. And the integrand, we still have 3z, but now we have e raised by x squared plus y squared. We want to write it as e raised by r squared. So now we're in cylindrical coordinates. And now this is easy to integrate, right? Because all the lower limits and upper limits are numbers. So let's integrate. So this 3 we can pull outside, change the color. So this scalar 3 you can pull outside. Then in z direction, we have just z, right? So integrate z, we have z squared divided by 2. Then we want to integrate, we want to calculate from 0 to 3. And theta direction is just constant, right? So just have 2 pi minus 0, which is 2 pi. And in r direction, well, let's see r direction, we have e to the r squared. If we take a derivative of this, we have e to the r squared. then multiply by chain rule 2r, 2 times r, by dr. So we have r e to the r squared dr. We have r e to the r squared and dr. We have these three terms. We're just missing 2. So what we're going to do, we're going to offset by half. Right? Offset by half. Then we integrate this. So basically, we multiply by half, we multiply by 2 here. So then this one, just the derivative of e to the r squared. So when we integrate, we just get derivative integration, we just get e to the r squared. E to the r squared. Then we want to evaluate r from 0 to square root of 2. All right, now let's do the calculation. So this half cancel with this 2. So we have a 3 pi by 3, or maybe evaluate z first. Z squared, 3 squared is 9. Z equals 0, nothing. So we have 9 over 2. 9 times 3, we have 27. So 27 over 2 and pi. E to the r squared. Well, r squared is square root of 2 squared, which is 2. Right? So we have e to the 2. Then minus e to the 0. E to the 0 is 1. So that's it. That's the answer for this integration.